All right, so hello everybody. Welcome to like week 12. We have 3 weeks left. So if you're here, please turn on your cameras so we start. We share the screen. How many people we have here? One, two, okay. Good. Okay, so today I'm going to start talking about stats and statistical analysis, continue to talk about quantitative research. And so what we're going to do today, I'm just going to give some basics about statistics. And then hopefully by Friday, we can do some exercises. Then I'm switching back to talk about experiments next week. And the week that follows, we'll do some exercises and statistics again. And that'll be, then that'll be it, right, for the semester. And so we're going to cover this week, hopefully, all of this. So variable relationship, analyzing quantitative data, presentation of finding, and discussing the software used for statistical analysis. So we'll start talking about variable relationship. And so hopefully at this point, you know what a variable is, right? So when you talk about two variables or more than one variable in a hypothesis, and the idea of quantitative research, we said, it's not about exploring some topics, but the idea of quantitative research is it enables you to test certain hypotheses. And testing hypothesis means you have one variable and you want to see if it's related or unrelated to another variable, or multiple variables for that matter, and how are they related. And so in terms of these relationships that you want to test in a quantitative hypothesis testing research, is like, first one we said that earlier, is that correlational. That is to say, two things move together, right? For instance, like increased height with increased speed in athletes, there's a correlation, right? Or like increased use of social media and increased use of online shopping websites, right? So these two things go up together. Causational. So causation is actually one form of correlation. So two things vary together, but in a predicted order. So it's not only that two things changes at the same time, but we know, or we assume we know, which one changes the other, right? So increased exposure to the sun could get you like sunburn, right? If you hadn't been exposed to the sun, obviously you would have not been sunburned. So the two things did not just come by a third variable or just happen to coincide with one another. There's a predicted way for doing this. So exposure to advertisement and then preference for the purchase or awareness of the brand. So if you haven't watched the commercial, you would not know or wouldn't remember what the brand is, right? So that's another type, which is causation. So X causes Y. And then there's no relationship. So there's no covariation with one another. There's no effect of X to Y or Y to X, right? And so these type of relationship are going to be related into which statistical methods you're going to use. And we're going to talk about that in a minute. And so then when we talk about correlation and causation, keep in mind, like, there are like two descriptions we give to them. We say this like a positive correlation or a negative correlation, or like a positive relationship or a negative relationship. And when we say positive, there's a positive correlation. That means when one increases, the other also increases. So they all go like in the positive direction. Well, I should point this way because right. So they move to right. So yeah, like more money you get, more things you could afford, right? So making more money, purchasing more things, two things increasing at the same time, right? Or higher income is correlated with like better subjective happiness, let's say, right? So that's a positive correlation. One increases, the other increases as well. Negative doesn't mean no relationship, and many people get confused about this. Negative means they move together but in opposite direction. Okay, so your grades decrease. So when your grade decrease, your level of depression increases. God forbid, right? But that's like an example, right? In terms of like, if you want to give examples in terms of communication and media, so more uses of social media equals less productivity in work or education, stuff like that. Or like when the examples we studied weeks ago, more hours spent on social media before going to bed decreases the quality of sleep. So that was an example of a negative relationship, right? Here I'm giving an example. Yeah, increased use of social media, increased motivation to work. And by the way, when we say negative relationship, doesn't mean negative in a moral sense or a social sense. Negative means it decreases the other thing. It's not like it's a negative outcome. So it could be, for instance, that, for example, there is a negative relationship between use or like hours spent working out, and then weight would decrease. So your weight will decrease if you work out more. That's like a negative relationship in a statistical sense, even though in a social sense, we would say that's a positive outcome. So yeah, make sure you don't confuse the two. Like we're talking about negative relationship, we mean in terms of like statistics, negative versus positive, not necessarily negative versus positive outcome. Okay. So why we do, so here's the idea, like, so why we do statistical relationship and why it matters. Because there's also something we call spurious relationships. That is to say, when you get something close to a perfect correlation or a strong correlation, but there's no relationship, there's no logical relationship whatsoever between the two variables, right? There's this website right here, and yeah, I could give it to you if you like, tell or given. And it's basically, you would look into any trend or any like chart that exists, and some trends in one area would match up to like amazing level, like almost like a full match with something that is totally unrelated. So here, this specific chart, it's showing you the numbers of doctorate degrees granted to in engineering, so engineering majors. So you see right here, that's the black line, and then the red line is mozzarella cheese consumption, and you could see it's almost like a perfect match, except for like 2 years you get some sort of like a diversion, but it's like a perfect match. And statistically speaking, so you see right here, correlation is almost 96%. Statistically speaking, they are correlated. Logically, they're not. And the reason is there's no way you could logically infer that number of engineering doctorates guaranteed would contribute to mozzarella cheese consumption. That's like a totally spurious relationship, right? And we gave example for that before. So like, so this is totally arbitrary, right? So it just happened because there's so many stats in the world. And so it could happen that like two randoms from totally different areas could just match, right? Because it's like a lot of numbers we could align together. But why we're pointing out to that? So remember, the idea we said in quantitative relationship is you want to show that there's some sort of like cause and effect. So what we're yearning for is to show a causational relationship. But sometimes two things could just coincide. And then the idea with like two things, you have to provide a logical explanation of why you think there is a coherent relationship. And that's what we call theory. So if you remember, theory means it explains the relationship between two variables. That's what theory is. There is like a logical explanation of why these two things are covariant together. And the second one, which you're going to talk about in the last week of semester, is something called control. That is to say, when you control for other variables, this relationship would still stand. One example we gave earlier in the semester, if you remember, so the number of, so shark attacks on the beach, so sharks attacking people on beaches increases when sales of ice cream also increases. Right, sales of ice cream increase, attacks by shark increase, okay? And so there's a correlation. And the explanation was, someone remember the explanation? When does ice cream, when do ice cream sales increase? In which season? Anyone remember which season?
During the summer.
Yeah, so during the summer, right? So during the summer, you get more people buying ice cream and more people go to the beach. And it also has to do with sharks also seeing more people coming closer to the beaches, and so you would witness more shark attacks. But it doesn't mean ice cream magically attracts sharks into, closer. That's the idea. And so it could happen that in your research, you could just find there, like in the research that we discussed before, remember, like there's a relationship between low self-esteem and use of Instagram. And it could be that it caused by a third thing. So there is a correlation, but it could be that people who are already insecure just spend more time on Instagram because they have nothing better to do. Hence, they would just show a correlation. But it's not Instagram that is making them lose self-esteem. So that could be one argument, right? Okay, so moving on, so that's one part of like why we're doing statistics is to show relationships. Then how we're going to look at data and evaluate them. So before you start, the first thing you should do, so here, not even if you're not running the analysis, even if you're reading a paper, that's the more important thing, is like to look at the sample size. So the idea we said of quantitative research is that you could have a more generalizable sample because, well, surveys are shorter, so you can recruit 200, 300, 500 people to answer a 3-minute survey and get a more representative sample. So the larger, ideally, so that's as a rule, the larger the sample, the more generalizable to the population it becomes. Guess one. And there are different measures into how to know which sample size you should settle on that we're going to talk about later this semester. But a decent sized sample with enough representation could also achieve generalizability. And that's what we call analytic generalizability. And so to remind you, so you have sample to population generalizability. So the proportions we see in the sample would match the proportion in the population. Analytic generalizability is saying, well, this sample, what the type of relationship we find in this sample should be no different than any other sample, right? And I'll give you, if it's like has a decent size and is more representative. And let me give you an example, right? Let's say we sampled, I'm not sure how many million college students like exist in the US, but let's just say we got like a sample of 500, all right? And we are measuring the effective video quality, so the quality of the video on Zoom, to information attentiveness or the ability to recall the content, okay? Let's say we found that the better the video quality, the more people are paying more, the more people are being able to recall the information or becoming attentive. So there is a relationship. We should, as long as the sample is representative, so we have male, females, like Caucasian, African Americans, the Latino, Latinas, Asians, you name it, like most groups are represented. We should not assume that any other sample would be different, right? So yeah, like there's a relationship between two variables. The sample is a decent size and it's equally representative, give or take. Yeah, then this relationship could be generalized. But that doesn't mean the proportion, and that's the key part, could also be generalized. So if 40% of the sample were able to recall the content of the lecture, that doesn't mean 40% in the population would be able to recall. It could be 35%, could be 45%. But the general trend, which is the higher the video quality, the better students are able to remember things, that should stand. All right, so do you see the difference here? You know what I mean? So the idea is, yeah, there is like a general trend or relationship or a theory that's being observed. And regardless of the proportionality, the general trend should stand across different samples. And so that's what the importance of the sample size with completed responses. So it's a sample size and with completed responses. And that's something you should pay attention to when you read like news pieces or research articles. So yeah, we recruited 600 participants in our study, but then at the very end, or sometimes could be like only like 350 completed. That means you have 350, not 600 and something, right? 350 completed the survey, then yeah, that's what would count. We also, we do something called like quality checks or intention checks. So I'm sure many of you have completed surveys before or evaluation forms. And how many of you done like the straight lining thing, right? When you just answer 555, 4444, 363 without even reading the questions, right? And since we know that happens and people do that, good surveys would have something called attention checks and quality checks. So attention checks would be, and I've done this before, like you insert a question right in the middle of the questionnaire, what's the color of the sky? Okay, and it would be like pink, blue, brown. So if you're paying attention, you choose blue. If you've chosen one of the other two, that means you weren't paying attention. So we will throw out that response totally. So that participant will be kicked out of our results. We won't count that as a legitimately completed response. That's what we call an attention check. And quality check would be, for instance, yeah, you would say, you would ask people about a question they just saw. So you play a clip from, I don't know, like a NBA match highlights, and then you ask them, okay, what have you just watched? They have to affirm that, yeah, it was like some highlights from NBA or basketball. So also, you know that people are actually taking your survey and not just arbitrarily completing it. So that's before you do anything with the survey. Now, with the survey results analysis. Now we are actually going to talk about statistics, which is what we're here for. And so to start, there are two type of statistics. They are descriptive statistics and inferential statistics. Descriptive statistics is you just describing the general trends in a sample. Inferential statistics is the whole point, which is you want to see if there's a relationship between two variables. Inferential is from inference, so you're inferring something out of the data you have. So descriptive statistic is a way to summarize the whole sample in like a few numbers that you could look at. Okay, common of them is like frequency, average or arithmetical mean, median mode, range of standard deviation, and crosstabs is also descriptive, but it's more closer to inferential statistics. And we're going to go over them one by one. So first is something called frequency table. So the point is like when you see this word frequency table, it's basically giving you a rundown of the people who participated, right, in your sample. So here, for example, you have percentage of respondents categorized by college year. And so if you look at frequency column right here, so here is like, well, valid responses, valid mean completed, right? So valid responses. Freshmen, you had 147, sophomore 96, junior 98, senior 65. And then you get the total. So it means what it means. It's just giving you the breakdown by each group right here. And then you see you have cumulative percent. So you have like raw percent and cumulative percent, what percentage each group is. And then you have the cumulative percent, which is adding up, like stacking them above one another until you get into like 100. And this one to make sure that you covered all of the samples. So it must always ends up totaling 100, right? So that's called frequency. So when you see it in an article, that would mean like frequency table. Okay, how many people or how many individuals were in each subgroup? And then we have the arithmetic mean or average, which I'm sure all of you know what an average is, right? You know how to calculate an average, right? Hopefully. Okay. So the average is like the total value divided by the counts, or like the number of units or item within your sample. So here, like assuming these are the cases, I have 17 participants, let's say, and each one in a question. So to what extent are you motivated to come to class? So if it was from 1 to 11, let's say, right? So it was like 1, 1, 3, 3, 3, 4. So this is each number per each participant, a number per each participant. I calculated the sum. I'll get 81. Then I'll divide it by the number of people. So it's 17. So the average here is 4.76 out of 11, right? So the people are not motivated, let's say, in this case. So you see, yeah, see, that's the average. Then we have the median, which is different. The median, you don't have to actually calculate the total. The median is the exact midpoint in a sample, regardless of the highest and lowest, what the highest and lowest values are, right? So right here, the median is 1, 1, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 6, 7, 8, 9. You could see here, like I have 7 numbers to the right and 7 numbers to the left. Okay, and so the exact midpoint here is 4. So it's between 4 and 4. So if you have odd numbers, you have 2 midpoints, because if you have even numbers, sorry, you have 2 mid numbers or mid units. So you calculate the whatever is in between those two. If you have odd numbers, it's better because you would have one half to the left and one half to the right. So that would be the exact midpoint. And that would be called the median. You might ask, why would you need to know the median? Then I'm going to ask you a question. Could you calculate the average of this number series right here, real quick? Could you calculate this average? You could use a calculator in your cell phone or laptop. So the average is 1 plus 1 plus 3 plus 3 plus 3, etc., divided by the total number, which is, which is 16 in this case. So could you do that? Get the total and divide it by 16.
$63.56.
What did you say?
I got 63.56.
Oh, did you divide it? Then you have to divide it by, that's the total. So then you need to get the average. So you have to divide it by 16.
Oh, crap.
Don't get it?
Yeah, 4.5.
Yeah. That's, what did he get? Let's see. Oh, Grant, he get 4.5. Well, I got 4.76. Or maybe missed one something. Anyhow,
I got
what did he get
4.5.
right?
I got
4.5.
4.5 as well.
Huh. So I could be mistaken here. Anyhow, not an issue. My larger point is, you could see sometimes that the median, either if it's 4.76 or 4.5, still the same thing, which is that the median is below the average. So the mean is 4. Let's say 5, and the median is 4. And so if you want to look, why do we do the average or the median? Because you know the median or the mean. We know, okay, what did, so imagine we're talking about a test in a score, like scores, test scores, right? If someone asked me, what did the average student got? Did I give the points of the students right in the middle? So if I have 21 students, I'll just, so student number 11, that's the one in the middle, right? And so that should, yeah, that's what the average student would get around. Or I just calculate the mean. And the idea is, most like in normal cases, the median and the mean should not be farther away from one another, right? So you should only see small differences. But to the degree to which the mean deviate for the from the median, that's called skewness. Okay, and you get a skewed sample is the more the mean is drifting away from the median. And let me give you an example, right, to illustrate the point. So back to the one about the exam and like points or scores. So say, for instance, we run an exam, we have, let's say, 30 students. I got, for, let's say, 4 students who did really, really well, got like a perfect score, 50 out of 50. But then the majority of you, not you, but students, other students, got around like 25, 30, something like that. But because I have 4 high achieving students, when we calculate the average, it will pull the average up, right? So you would say the average around like maybe 40. But actually, most students get below 40. Okay. That's why we need to have both the median and the mean. Because yeah, if the median was way below, that means yeah, we just have like a few cases on the high end that just artificially pulled the average up. But the median student got way below that. So do you get the point, right? If we invite, let's say, Elon Musk to this meeting, the average wealth of the group would just way, the average income of per person in this meeting would be way up, right? It would be like, yeah, in billions of dollars. But it's only Elon Musk, right? Elon just pulled the average up. But if we look at the median, we just look at, okay, who's like the richest among us, who's the poorest among us, and let's look at that person in the middle and what's their income. And so that's the actual median. Okay, so that's why we do both. So that's the median and difference between the median and the mean. Then we have something called the mode, which is also similar. The idea is that like you want to see, okay, how can I summarize this sample more faithfully or accurately, which is to look at the value with the highest frequency. Okay, so here, for instance, we have 1, 1, 1, 3, 3, 3, 4, 4, 4, 4. So 4 people who scored 4 here were like the plurality of the sample, because 5 people got 4. And so that will be the mode. So the value that appeared the most. And you can see why that. Also, if you think back to the example about the exam scores, so what did like most student or plurality of student got? Okay, so if you know a plurality of student got around, let's say 40 out of 50, and then the average was also around like 41. So yeah, you would see, okay, so this is all aligned close to one another, right? There's this more like a normal. So that's the mode. Here it gets a little bit tricky with range and variance, and we're going to stop after this, and then I'll make you do some exercises in our recorded video. And so a range, so the idea, as we said before, you always want to see if your sample is evenly and normally spread, or it's like skewed somewhat either into the extreme positive side or extreme negative side. So there are 2 measures exactly aimed for that. First one is called the range, which measured the spread of the values from the lowest to the highest. Okay, which is very simple. So you get the maximum value in your sample and the minimum value, and then you subtract the minimum from the maximum. Right. So that hence you get the range. So here, if people scored between 4 and 8, so the lowest got 4, the highest got 8. Yeah, so 8 minus 4, your range is 4 points. From the lowest to the highest, the range is 4 points. In an exam, right? So say it's out of 50, so the lowest got 15, the highest got 50. So the range would be 50 minus 15, which is 35, right? So it gives you like, yeah, how like who can give, right? I think logically you could infer the lower the range, the more clustered the values were, right? So if your range is 2, so students, yeah, so or like participants were only ranging between 2 points, right? So it could be between 8 to 10 or 3 to 5. The higher the range, you would know, okay, this sample was more spread out. Okay, because yeah, the range of where people got in this sample, like yeah, was more spread than clustered together. Then we get something called the variance, which is once it's the squared average of how each value deviated from the sample mean. All right, and I'm going to show you the formula, which is not, don't get scared by the Greek letters. It's very simple. So the idea, okay, I want to see how far each participant or each unit is farther away from the mean or the average, right? So to do that, you basically just calculate the difference between each value and the mean, square them, and you square them, or like you square them statistics, so you get rid of the minus positive thing, right? So if you got 3 points above the mean or 3 points below the mean, it would count as 3. Because when you square things, you know, it's negative times negative, so it becomes positive. So you're not interested in direction, you're just interested into how far it is from the mean, right? So hence you square them, you get the average of that, and yeah, and once you get that, you basically get the number, right? So standard, so in other words, so the variance, also the same case. So if if the variance is high, you have a high variance, you would know your values in average were further away from the mean of the sample. Okay, if the variance was small, you knew the values were very close to the mean, right? And you could try, actually, I'll do an exercise for that in which you could calculate the variance to get the point, right? But assuming, yeah, the average was 15, and we have 5 people, right? The average was 15. 2 people got 13, 2 people got 15, and 2 people got 17. Yeah, the variance, so you calculate the average to the mean, it's 2, right? So that would be number in that square. Standard deviation, and you would hear that word a lot, is when you get the square root of the variance. That's it. And the idea of getting the square root, because the variance is squared, so to get it back, you get the square root. And you might think that's ridiculous. Why? Okay, I take something to the power of 2, and then I take it back I take the square root. Then why did I do the taking it to the power 2 in the first place, right? I'm doing it the same thing. Well, the idea is like you want to smooth the differences. So you want to get rid of the minuses. Basically, that's what you want to do. You don't want you're looking at the absolute value. You want to get rid of the minus scores. So yeah, if you get like 2 below or 2 above, so you got the square root. Sorry, you got the square power. Get rid of the minuses. Then you want to go back to the normal value, and so you get the square root. That's why they do it. Okay. So that's okay. So here we're going to do the exercise, and so I'm going to pause here, and then I'll record this part, and then make you do an exercise online. So we stay faithful to the time. Do you have any questions? And before we leave, has any of you started connecting with the group members that you were assigned with?
My group has.
Okay, so just a friendly reminder, so if you haven't, please reach out. Yeah, like try to have your first meeting, and let me know if you have any questions, okay? Right, so if you have anything, then I'll see you next time. Take care.
Thank you.
Thank you.